Polarization. This is the characters of the wave nature of light. Okay. Generally, polarization means we have to reduce the intensity of light. For example, during the night time, in the road, the two-wheelers, they put in that light to the headlight. Okay. For opposite person, they feel some little bit glare to see the road clearly. Okay. So we have the headlight doom light. No, it's called doom light. The mirror is made like this. It's a thin mirror. So make the small lines like that. Okay. It is used to reduce the intensity of light. Okay, which means which can allow the light vibrations occurs only in one direction. Okay, that is called polarization. Okay, so we have to reduce the intensity of light. Okay, so let's see the definitions. Restrict the vibration of the light to a particular direction that is perpendicular to the propagation of wave. Suppose wave propagation like this means, so the molecules are vibrating like this direction, only in a perpendicular direction. Okay. Then it proves that light waves are only in the transverse in nature, because it's the meaning of transverse wave. So the wave motion of light in transverse wave means this is the only proof. Okay. So using this concept only, you can treating with character of light, the wave motion is in transverse. It's not in the longitudinal wave. Okay, but sound wave is a longitudinal wave. Okay. So using this concept, we can find the polarizer, analyzer also. Okay, and also we will do the Malus law. Okay. Next, we will see that what is the function of polarizer and analyzer. Okay. First of all, we should know about what is the meaning of unpolarized light. See, this is the source of light which can vibrate in all the directions. Okay, this is the meaning of unpolarized light. Okay, so take that one polarizer is made up of the glass. So draw the make the hole like this. Okay, this means which can allow the light only in one direction of vibrations. So for the light of the unpolarized light, okay, so the polarizer say P1, which can allow the only one direction of light, which is parallel to this polarizer phase. Okay, so the unpolarized light is falling to the polarizer, then became a one direction of vibration. It's called polarized light. Clear? So the emergent beam is further is passed to the another polarized we have placed here, say namely P2. Okay, it is a rotated diagonal. Okay, like this. Rotated diagonal means you can see that maximum intensity. Okay, and the polarizing light when the two beams have become parallel. So this line is right now when the rotation takes place means it becomes straight line. Correct? So when the two points are kept in parallel means you can see the maximum intensity of light. It's called polarized light. Maximum intensity. Again, you have further rotation means you see that the intensity of light will be decreases, and finally the rotation takes place up to the 90-degree means like this. Okay, we can't see that light after this analyzer. Clear to you? That is called plane polarized light. Okay, so the first polarizer, okay, which means it can convert that unpolarized light into polarized light. It is called as polarizer. Okay, the second polarized P2 is used to examine whether a beam of light, okay, is polarized or not. That's called analyzer. Okay, the polarizer means it can convert that unpolarized light into polarized light. Analyzer means it is the examine the light comes to the polarizer after polarizer, whether it is polarized or unpolarized light. Okay, so what is the intensity of the light means? Say intensity of unpolarized light, say I. Okay, then it will become that falling to the polarized P1. So intensity will be decreased by 2 times. So we can write I by 2. The intensity of light is I. Here I by 2. The other half of the intensity of light is restricted by the polarizer P. Clear? So next we will see that plane polarized light and partially polarized light. Okay. This is a graphical representation of the plane polarized light and partially polarized light. In x-axis, we can take the rotation of the polarizer or analyzer with the angle of t equal to 0, 90, 180, etc. like this. In the y-axis, we take the intensity of light we are seeing after the two polarites. Okay, so at the 0 degree of the analyzer, okay, the intensity will be maximum, which means both the polarites P1 P2 are kept parallel to each other, so we can get the maximum intensity of light, polarized light. Okay, then the rotation of the analyzer alone, okay, keeping the polarization in the parallel. Okay, so for the rotation of the analyzer with the degree of 0 to 90 means the intensity of light will become 0, which means in this cases the analyzer, that is the second polaroid, is purely perpendicular to that first polaroid named called polarizer. So P1, P2, P1 is called polarizer, P2 is called analyzer. Both are comes to the perpendicular direction means it will become 0. We can see that intensity of light. For the rotation of the analyzer alone, so the angle will be equal to 180 degree. So that time also we can see the maximum intensity of light. Here the intensity of light will be decreases up to 0. The rotation means it will become increasing up to the maximum value. Okay. So the rotation of that analyzer, we can see that the intensity of light will be maximum, minimum, again maximum goes on. Okay. So if the intensity of light is varies from maximum to 0 for every 90 degree rotation of the analyzer, that is called partially plane polarized light. Okay, maximum then 0, maximum 0. It comes like that. Okay, if the intensity of light is initially is a maximum, or is not come to the 0 as a minimum, so it has some value, is not 0. Clear? If the intensity of light is varies between maximum and minimum is not to be 0 for every 90 degree rotation for the analyzer, the light is called partially polarized light. Okay, so plane polarized means maximum then minimum as a 0. For a partially polarized light, maximum but minimum is not 0 for every 90 degree rotation of that analyzer. Okay. And next is Malus law. It's a 3-mark question, important. Okay, it is used to find that what is the relation between the intensity of light with the angle of rotation of the analyzer. Okay, see this unpolarized light, so vibration in all the directions. Place a polarizer which can allow the light only in one vibrations. There is like this direction. So this light is called polarized light. Okay. So unpolarized light passes through the polarizer, which makes a vibration of light only one direction. It's called polarized light. Okay. Now we have to rotate that analyzer with some angle to make the intensity will be reducing or increasing, whatever. Okay. So the rotation of analyzer between the two lights is also polarized light. Okay. So what is the angle takes place here for getting that changing its intensity? Okay. So the plane polarized light of intensity I0, okay, is incident on the analyzer. The light is transmitted of the intensity I. Okay, so I0 is what? Intensity of light before entering the analyzer. It's called a plane polarized light. Here, the intensity of light will be I. For the analyzer is various directly proportional to that square of the cosine of the angle between the polarization and analyzer. Okay, so the intensity of light it varies how, so you can measure it. Okay, so we have to find the equation relation between the intensity of light before entering the analyzer, then after getting that analyzer. Okay, so formula is for formula I is equal to I0 cos square theta. So I0 is the plane polarized light before entering to the analyzer. I is the intensity of light after getting from that analyzer. Okay, this is the Malus law. So how can you prove this? Means the intensity of light is directly proportional to the cosine of the square. Okay, so that is cos square theta. Okay, with the value of A is the amplitude, so put A square also. Okay, So I is directly proportional to a square cos square theta, but a is called ambient of the wave. Okay. The proportional we put equal means you have to multiply one constant. So I is equal to k a square into cos square theta, where k is called constant of proportionality. Okay, so we'll write as this constant, say k a square is equal to I naught. Then we'll get this equation, I is equal to, we'll write that k a square is equal to I naught, then cos square theta. Okay, so this is the formula for the modulus law. Then we get the maximum and minimum for the value. If the theta is equal to 0, this means the analyzer kept the 0 angle, it is parallel to that polarizer. Okay, you know cos 0 equal to what? 1. So that I is equal to 1 into I naught, I naught. If the theta is equal to 90 degree, then cos 90 is equal to 0. So 0 into something 0. So intensity will be 0. Okay. Here the angle between the polarizer and analyzer is parallel, it is perpendicular. So the rotation of the analyzer which determines the intensity of light. Okay, we get maximum and also minimum. Okay. Next we will see that what are the uses of polarites. Okay, so we are using that headlight. No, I told the headlight of the 2-wheeler or 3-wheelers. Okay, it is made by the very special thickness of the material of the light as mirror to reduce the intensity of light. Okay, that also one type of the use of polarites. Okay, so polarites are used in goggles, is meaning of mirror. Okay, and cameras to avoid the glare of light. Okay, there is a first uses of the polarites. It's a mirror. Second thing is polarites are used to take 3D pictures. This is called holography. 3D means you can make the different kind of the pictures of the single image, single object. Okay, so you can modify the mirrors and then get the 3D dimensions. So all of you see the 3D pictures using that, wearing this on small mirrors that is made by that polarites. Okay, polarites are used to improve contrast in the old oil paintings. Okay, so you can use in this specialized specs like that to see that whole oil paintings with the light contrast. Okay, polarites are used in optical stress analysis, obviously. Okay, polarites are used as window glasses to control the intensity of incoming light in case of we are traveling in the aeroplane. So aeroplane means it will have fly above the surface of earth. So there are so many of light rays are possible to flowing at that. So to avoid the glare of the sunlight, they are using the two different polarites of the light as a door. Okay, so we can adjust the inner window of the made of the glass light to get that, to avoid the glare of the sun rays. Okay, polarized laser beam had as a needle to read and write in compact disc. That's called compact disc, CDs. Okay, so you can read and write with the help of your polarized light. Then finally, polarized light is used in a liquid crystal display. That's called LCD. So using calculator or using that watches also. Okay, we can see that the display of the LCD display. So the glass is made up of the polarized to reduce the intensity of light. Okay, to get the clearing in the what is the function is adding on the doing which are possible done by the instruments like calculators. Okay.